Hello everyone, how are you? Thanks, Mr. Johnny. Okay, let's share the screen. Canvas. Yes, yes. You guys can see my screen?
Yeah.
Yeah, I can see your screen.
Okay. They can see my screen, which is good. Any question from the last lecture?
It seems straightforward to me.
Good. So we stopped at the Brits first search, right?
Correct.
Mm-hmm. Okay. We're still waiting for another two. Let's wait another minute. So guys, I forgot. Yeah, so I sent you maybe 10 minutes ago two codes, two MATLAB files that we're gonna use today. Okay. So I sent them on Canvas. So just download them right now and start them using MATLAB. Okay. Because after maybe 15 minutes, we're gonna use them. We're gonna code together. We will not code from scratch. I put the basic skeleton inside the files. We will just, fill out some specific parts. Okay. Of course, we will have errors, no problem, and we should debug them together. That's fine. Okay, let's get started. So the last thing we stopped at last lecture was Brett's first search. Okay. Now we're gonna start with another search algorithm, which is depth first search. Okay. So the basic idea of Brett's first search is to go, on a wider range, like a circle. Okay. Sometimes they call it grass fire. So this is actually another naming and conventional naming for Brett's first search. It's called the grass fire. Because if you have an area that's filled of grass and you start some fire, it will go, like radially like this. Depth first search, on the other hand, is no. It just takes one possibility and go depths in this possibility. Okay, until all the possibilities that came from this initial, we can say, solution candidate or search path is ended or exhausted. Okay, so we're gonna see an example together now. I'm gonna check first something. Yes. So if this is our start node here, this is number 1. Okay. So we're gonna choose either left or right because you know node 1 has 2 connections to the right and to the left. So let's start by the left. So this is our choice. We can do the opposite. That's fine. So okay, we're gonna check the node on the left first and call it 2. Okay. Now this is a node in hand right now. Okay. Whenever we have a node, we explore this node. Okay. Not like the breadth first search. It will go 1, 2, 3, for example. No, here we take one of them and go from that path forward. So this is the node in hand right now. This is the last candidate we get, or we have, or explored from our tree, or I'm sorry, graph. Then from 2 we continue. 2 also has 2 neighbors or 2 childs. Okay, it's like a tree here. This guy and this guy. Again, we're gonna go with the left first. So 3. And we leave this. This is now the node in hand. So let's explore it. It has also 2 childs. We go with the left first. 4. This is now the node in hand. This is the last thing we get. Okay, from there we go. So 4 also has 2 kids, yeah, children. So left first, so 5. This is now the node in hand. This is only one possibility left for it, which is this, so 6. 6 has no. So this pass now from 5 at 6, we are now sure that we cannot reach our goal. So the goal could be one of these. For example, this is the node of the goal node. Okay, so we are sure now, since we didn't pass through any node which is the goal, and the 6 has no children as a parent node, then we are sure now that 6 has no reachability to the goal. Then we go back one step to 5 and ask ourselves a question. Does 5 has any other possibility? Any other node connected to? No, it was no. In that case, it's no. It has only one node which is already explored. So we go back one step, another step, to the parent of 5, which is 4. Does 4 has other possibilities? Yes, which is this one. So this is 7. And this is the last nodes that we get right now. And we'll explore from this node. 7 has 2 possibilities. This one and this one. We go as usual as on left. So this is 8. 8 has 1 possibility or 1 node connected, which is 9. Does 9 has any children? No. Does 9 is a goal node? No also. So we go back one step. So the search stops here. We go back one step to 8. Does 8 has any other connection? No. So we go back another step to 7, to the parent of 8. And 7 has another possibility rather than 8 and 9. So this will be number 10. And we start from this again. 10 has 1 connected node or 1 child, which will be 11. Oops. Okay. Does 11 has any children nodes or leaf nodes? No. So we go back one step. Does 10 has other possibilities? No. We go back another step to 7. 7 has, we have explored all the possibilities that came from 7. So we know for sure that 7 has no reachability or connectivity to the goal. So go back one step to 4. Does 4 has any other leaves connected to or children as a parent? No. It has only 2, 5, and we explore all the possibilities of 5. It has also 7, and we explore also all the possibilities of 7. So we go back one step to what? To 3. Does 3 has other possibilities Other than 4, yes, it has. So we go from there to 12. Does 12 has any leaves connected to? No. So we go back one step. Does 3 has any other possibility rather than 4 and 12? No. So we go back another step to 2. And here we ask the same question. Does 2 has any other possibility? Yes, it has this one. So this will be 13. And we continue in the same way. So let's check if our solution is right or wrong. Yes. So 2, yes, this was 12. Let's check. This was 12, right? Yes, this is 10. This is 10. Yeah, that's right. So we are correct. Okay. Of course, if I'm drawing now using the PowerPoint tool itself. Last time we were drawing using, you know, this tool from Zoom itself. So when I flip the screen, or I'm sorry, when I go to another slide, I see the two, the drawing and the next slide together, so you can check. But anyways, now I'll give you guys 5 minutes to check the node number of A and the node number of B and the node number of C. The exploration step of A, B, C. So for example, this number means we explored this node at step number 12, okay? So I need the same numbers for A, B, and C, okay? You have 5 minutes, guys. If somebody finishes early than 5 minutes, just, you know, speak and let us know the solution. I have a chat here. Let's check them. So I see, guys, 19, 24, and 32. This is from...
That's what I got.
Yeah. But your name is Genesis? Or...
No, my name's Alan.
Okay.
My name's Genesis.
Oh,
Genesis,
yeah. Genesis
okay.
got. Oh, I didn't see the chat. Yeah, Genesis.
Okay. Okay, Mr. Genesis. So let's check 19, 24, and 32. So let's check that. Okay. Oops. I didn't put the solution, but let's do it together. That's fine. If you all guys got it, but we can check at least A. So this is 12. We go back here. This is 13, 14, 15, 16, 17, 18, 19. That's right. That's what you got? Yes. Then we go back here, we go back here, no possibilities, we go back here, no, we go back here. Then yeah, this is will be 20. Then 21, 22, 23, 24, and you know the rest is easy. Okay. So guys, the basic idea is that with depth first search, we what we have in hand, we explore it. Okay. So with breadth first search, it was FIFO-Q. We needed FIFO-Q, first in, first out. Heat, we need a stack, right? Stack queue, not a FIFO. We need first in, last out, or LIFO, last in, first out. All are the same, all are stacks. Okay, so this is what we basically need for depth first search. Okay, let's take an example with a grid or map like this. Okay, this is the same example that we did for breadth first search. And with breadth first search, I believe we reached the goal at the step number 29. Okay, we can check this very quick right now. 25. You see 25. So let's see what we're gonna do with depth first search. This was 25, not 29. Okay, again, we should set some priority. Up, then left, and right, then left, then down. Okay, so we start as usual by the starting node. We go up first. So this is one. And we start exploring from the last thing in hand, or the current thing we have in hand right now, which is node 1. So we'll explore from 1. So 1, we start up again, it's 2. And we start again exploring from 2. 2, up again, 3. Starting from 3. 4. Starting from 4, 5. And this is the goal, we are done. So in here, depth first search give us the solution in 5 steps. Also, breadth first search give it the solution in 25 steps, 5 times bigger. Does that mean that depth first search is better than breadth first search? No, it's just, coincidence. For other examples, it may be worse, it may be better. It's not, it's not, they are comparable to each other. So let's have another example to prove that. So you have, guys, let's say 5 minutes again. Okay, if you needed more, just let me know, to solve these 2 maps using depth first search here and breadth first search here. Okay, the first one to finish, just share me your screen. Okay, I will let you to share your screens, but just when you finish, just raise your hand or just speak to see your screen. Okay, we have, guys, 5 minutes.
Are we using the same priority as the previous ones?
Yes, same priority. Up. No, let's see. Up, right, left, down. No need to share the screen. Just let me know the number of steps in the breadth first search and the number of steps in the depth first search. No need to know the exact details, just the number of steps. Any news? At least one of them. So we have here Chris, right? Reached 29 in here. And he's still working on the DFS. And Clark, right? Got here 33. Let's do that. Anybody still working, or you guys are has finished? No. It's not 5 steps. There's something in the 30s. So basically here in that example, DFS will take more steps than BFS. Just a check for you. Okay. So I think the 29 and the 33 are, good candidates for the solution. I can't remember myself. I will do it together with you. Okay. Let me do it with you. Okay. So let's start by DFS. Okay. So this is our starting node. Okay. We go up. So 1, start from the one in hand, which is 1 here, 2, 3, 4, 5, 6. At 6, we can't go up, can't go right, can't go left. So this is 7. At 7, we can't go up. We already explored this. We can go left. So this is 8. At 8, we can't go up. We explored this. It's here. This is just a wall. This is an obstacle. So we give up on it, and we go back to 7. At 7, we explored. I'm sorry, we couldn't explore the up. We couldn't explore this because it's already explored. We explore this. Another possibility is here. So this is 9. We go from 9. One possibility 10, 11, 12, 13, 14. At 14, we go 15. 15 up, already explored, right? 16 up, already explored, right? 17 up, 18, 19, 20, 21, 22 up is an obstacle, right? It's not explored. 23, 24, 25, 26, 27, 28, 29. At 29, up is explore, explored. Yes, this is a wall here. It's the end of the map. Then right, then left. So this is 30. Up, explored, right, explored. Left is not explored. 31. 32. No possibilities. Go back to the parent. This was the parent. No other possibilities. Go back to the parent. This is the parent. This guy. So 33. 33 explored. Not explored. 34. Chris got 34. That's good. Okay, this was wrong. Okay. But it's very close, you know, that's fine. 34. Now let's see Brett's first search. Okay. So 1, 2, 3, 4. Then go with the, so look at the minimum. Usually look at the one with the minimum steps, then go from it. So this was 1, this is 1. So 5, 6, 7. 2 here, 8, 9, 3 would be 10, 4 here is 11. Then what is the minimum here? It's 5, so 5 again, 12, you know, 13, 14. Then we go to 6, 15. If I am not like the ones that you have, just, you know, debug me. Say, yeah, there is a problem here. The numbers that you have is different from mine. So the minimum again, so 6 here, 7 is 8, so 16, 9, 17, then 10, 18. This should be right. 18, then the minimum again, which is 12, in here, 19, 20, 21, 13, 22, 14, explored, 15, 15, where is 15? There is no, yes, 15 is explored, 16, we can have here 23, then 17, where is 17? 24. Then we are looking for 18. Then 19, where is 19? It's in here. So 25, 26, 27. Then after that, we go to 20. Where is 20 here? 28. Then we go to 21, 21 explore, 22. Where is 22 explore, 23? Yes. So this is 29. So the guy, yeah, that's the right answer. So here is 29. Here is 34. So I'm just giving this example to stress the idea. Okay, let you do it yourself, just to, you know, practice it. And to prove that it's not always DFS is better than BFS, depending on the example. Actually, BFS is a complete algorithm, meaning it will give you the route from the start to the goal if one exists. And if there is no route from the start to the, for example, if there is a wall here, you know, all that is just a wall, okay? It will give you an empty route array, meaning there is no route, okay? And it guarantees also the shortest path. So it can give you, it will give you the short, if there is a route, it will give you the best route to the destination or the goal. The DFS is incomplete. And the reason is very simple. If we go back here which is of course bad or worse than BFS in that regard. So if we go back here, assume that one of these routes here, for example, this branch here is an infinite branch. Okay, so DFS will go in that branch forever, and it will not go back because it's an infinite branch. Okay, that's why it's incomplete, because there is a possibility if you have an infinite branch in your tree or graph that it goes there and never come back. But breadth first search go radially like this, so eventually it will get to the answer if there is a route. So let's check the answers that we have. That's completely wrong. This is BFS. Because I'm sorry, I'm just but look, yeah.
I think you switched on purpose.
Yes, but look, if we look at that's right, because I switched them. So in the first slide, DFS was here, breadth first search was here, but I just switched them. Depth is here and breadth is here. So, but if we look at the answers, we knew that we reached the goal in breadth first in 29. Okay, which is this number in here, in magenta. And for depth first search, we reach it in 34. Right, 34. So I'm very sorry for this. I will switch them before sending you the slides. Okay. So this was, the difference between both. Now, to code breadth first search with MATLAB, there are some notes that we're gonna take into consideration. Okay, let me first, remove all that stuff in here. Oh, that's from Zoom, so it goes with you when you go from a slide to slide. So the problem with MATLAB is, let's use better the pen here. In MATLAB,
Professor?
yes?
Quick question. So earlier you were saying shortest path. Does that also mean account for time? So shortest path would be less time?
Yes, yeah. Yes. So it depends on the environment, okay, on the graphs that you have. So it will give you the shortest path based on the graphs that you have. In the context of maps, it will give you the shortest path in steps, the number of steps from the source. Okay. So for example, in this case, the shortest path is 2 steps. 1 step, second step. Okay. So in that example, if this is our example, BFS will return to you an array, which is a route array with the ID of this cell, and of course, this is just this cells because it's only from between the cell between the source and the destination of the goal. Okay, if the goal is in here, for example, it will give you an array with the ID of this cell, the ID of this cell, and the ID of this cell. Okay, so it depends.
Okay, yeah, no, because I was
the minimum cost. Let's say the one with the minimum cost.
Okay,
whatever the cost is.
Yeah, I was just wondering because it does take. Wouldn't it also take time to, let's say, like go back to a previous node or a node before that? Wouldn't that, like breadth first search, you would have to find the least minimum, so that would also take more time. So technically, the shortest path might not be the shortest time
So
to complete something. If you
understand
retracing your steps back.
I understand. So I'm not sure if I got this right from you, but I think you mix it two stuff together. So just to separate, if I'm wrong, just correct me. Separate two stuff from each other. The computation time or the computational work that the algorithm will take, and the shortest path. Okay, the algorithm may take a huge amount of steps to reach the shortest path, but it will give you the shortest path. So take this route. This route will lead you to the goal with the minimum cost. Okay, but maybe to get to the shortest path, to compute it, we need maybe some time, a lot of time, for example. Okay.
Okay, that makes sense. Thank you.
So let's see. So our problem now in MATLAB is that MATLAB has some problems. Not everything is licensed. So in MATLAB there is no queues. Okay, rather than C, for example, or C++, in MATLAB there is no queues. And remember, we needed for the breadth first search, we needed first in, first out queue. So what I have done, I came up with another idea just to walk around this problem. In your homework, you will have two homeworks. So you will do one of them is the ideal solution. Create a queue in MATLAB, then use it. I didn't do that. I left it to you. It's easy. It's not that hard. So what I have done, I have created an array. Okay. And that array has a length equal to the number of cells in our map. So for example, this map here has 10 rows, 5 columns, it has 50 entries. Okay. And it has 3 columns, this array in here. The first one is the node identifier. This ID for the node can be a number specific to this node or the coordinate. So for example, this node in here has a coordinate of 2 and 2. I mean row number 2 and the column number 2. But it's a little bit ugly to use the coordinates or the column and row indices for any cell. So we're gonna use something called array ID or cell ID. Okay. So MATLAB has very efficient, very good command or function that based on the coordinate of a cell, it gives you a specific number to the cell. So basically just a numbering. So I will do the numbering for you here. So this is 1, 2. Let's do another color. Red, for example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 40, 50, 29, 39, 49. This will be 28, 38, 48. Just to continue in that order. Okay, you will find that each cell has its own ID. And by the way, MATLAB doesn't do something magic here. It just takes the column and the row indices of any cell, and using some very simple equation, it generates these numbers to us. So we don't need to worry. It's just a command in MATLAB or a function in MATLAB. Just put the function, put the size of the array, the coordinate, and it will give you the ID of the cell. Instead of working with the coordinates, which is really, not convenient. So here is the node ID. Let's go back. The second column will be the distance from start node. Okay, we need the distance because we use this afterwards to determine the shortest path. The last column is the exploration step. As we see in the previous, for example, let's go to the previous example. So we need the number of steps. Okay, at least to compare to two algorithms together, but we will use it for another purpose in the code, as we will see now. Okay. In your assignment, you will add a fourth column that will help you to determine the shortest path. So I will not do the shortest path in this lecture. You will do it yourself. Okay. So let's go with that array right now. We have here very simple example because the goal is very close to the start. So as usual, the first node is starting node, which has ID of, if we continue, let's continue this IDs because it's very useful. So this will be 27, 37, 47. Okay, this is 26, 36, and 46. Just add here 4. Everything will be 4 in here. Okay, that's 3, 3, 3, 3, 3, 2, 2, 2, 2. This is 2, 3, 4, 5. Okay, that's right. There is 1. Okay, we completed it. Okay, so these are all the IDs that we need. Okay, and we need 2 pointers because we don't have FIFO, so we need always to check. We need 2 pointers. One of them to point to the first location that is free in the array, and the other one is to look for or point to the current node that we are exploring from, which we will call frontier. So this is called the frontier. Okay, so this is a frontier pointer, and this is exploration pointer, we can say. Okay. For the first node, which is the starting node, the ID is 27. The distance from the start is, of course, 0, and this is step number 0. Okay. Now, from a start, we go up, right, left, and down. So let's do that. So in here, this is 1, and for each cell you explore, add it to the array. So this cell here is not 1. Remember, this is step number 1. Its ID is 26. And the distance from start is just 1. Just add 1 to the frontier distance. 0 plus 1 is 1. And move the pointer to here. 2. Remember, this is a step. What is the ID of this node? It is 37. What is the distance from the starting node or the current frontier? We can say this is a current frontier, which is a starting node. Just add 1 to here, which is 1. Then 3, 3. Remember, this is not the ID. The ID is 17. The distance is 1. This is 4, Step 4, the ID is 28, and the step is, and of course I just didn't move the exploration pointer, then it will stop here. Okay, and there is no other possibilities for the starting node. Okay, so we move, since we explore everything with the starting node, we move now the frontier pointer. So the frontier pointer will move to the next element. Next. So here is the frontier pointer with 26. What is node 26? Which is this node in here. This is 26, which is the up node. Okay. So let's explore 26 up. So this is step 5. This is 5. Then and what's the ID, which is 25, and the step is the distance is 2. Just add 1 to the distance of the frontier point or node. So we'll add 1 to this, which will be 2. Then we continue. So this is 6. 6. What is the ID of this one? It is 36, and the step again is 2. I'm sorry, the distance is 2. And here is 7. This is 7. The distance will be 2, and the ID is 16. And this guy was moving all the time, and now we'll stop here. This is exploration pointer. We end exploring node 1. We move the pointer, the frontier pointer, I mean, to 37. Node 37. Where is node 37? It is that node. Okay, and we will continue in exactly the same way. Okay. So any question with this? Everything is clear right now? Okay, I assume everything is clear. Okay, let me start exploring the code that I did for this using such a kind of array. Okay, I will give you at what time we should finish. This is 3:45. So I will share now my screen for the other screen. Let me stop share this one. So this is these two files here, BFS main and BFS grid is our original. These are my original files that I did. Okay, I will just, which has all the solutions, exploring and also finding the shortest path. Now I will just run them to show you how the solution will evolve until it reaches the destination. Okay, and the gray here means shortest path. This is the shortest path. Okay, guys. So don't worry about the graphics of MATLAB. I did it for you. Actually, I got it from some code on GitHub. Okay, but I'm using it. It's very nice. So I will go with you through now the coding itself. So these are the two files I sent you. The main, which is just a file that contains the basic information that the algorithm needs. And here, the search algorithm itself, the breadth first search algorithm itself. So let's start by the main file, MATLAB file. In that file, we create the map, we assign the obstacles, we assign the free cells, we assign the starting nodes, the goal node. These are the basic information that BFS needs to calculate or compute the shortest path for us. Explore the map and calculate the shortest path. Let me here grab the Excel just to see what we got. Yeah, here's that one. Yes. So this is our basic problem. Okay. The start is in that is at that cell. The goal is at that cell. Okay. So first I create a map. Okay. And with the same size of the map, of course, that's our map here, which is 10 by 5, 10 rows and 5 columns. Guys, the font is good, or should I increase the font a little bit? The font of MATLAB, this font.
I could see it.
Good. If anybody can't see it very well, I can increase the font. Okay. Okay, so first I initialize a map with all entries as zeros. Okay. Then I will mark the obstacles with true or 1. Okay. So where are our obstacles here? These are the cells of the obstacles, the black cells. Okay. So we have from 2, cell number 2 or column number, row number 2 to row number 10. In the first column, these cells here are walls, true. We have then row 1 and 2, column 4 and 5 also walls. And finally, these two obstacles in here at row 10, column 2 and 3. Row 10, column 2 and column 3. Okay. Then we're gonna assign a start and coordinate and the goal coordinate. The start cell is here, which has a coordinate of 7. So it's 1, 2, 3, 4, 5, 6, 7. It's row number 7. And the column number 3. So this is a start node coordinates, and this is the goal coordinates, which is row 2 and also column 3. Don't worry about the comments, just other examples. Okay. This variable in here, okay, it's called what? It's called draw map every time. Okay, so you see the graphics that I showed you. This graphics, of course, needs some computational effort, and it may delay your computation. It has only the value of, visualizing the results, debugging and stuff. But if you don't wish to see this visualization, just put this variable as false. Okay. And this is just a test function. This is our function in here that will do the best first search for us. It takes, of course, the map, the environment, the start coordinate, the goal coordinate, and the visualization stuff is implemented in this function as well. So if you wish to draw, just put this guy as true and send it, so it will draw for you the paths and the exploration and stuff. This function returns the route, which in best first search should be the shortest path, and the number of steps. Okay, how many cells explored in order to get the shortest path. So let's see now the function itself. So this is just some hints, which is very useful for you. What are the inputs and what are the outputs? Okay, we know. I just explained it. Now for the visualization, and anything I mention for the visualization is for visualization. It's not for the true or the actual work that we want to implement, which is the first search. So if you miss something in here, you couldn't understand something from me, just forget it. No problem. Just use the function as it is. Okay. So to draw, MATLAB has a very useful function called image. Okay, it can draw you an image out of an array. Okay, but you need to give MATLAB, besides the image, you need to give it a color. You know, it can be colored also, and each color has its own, you know, value, we can say. So you need for this to create an array. Call it whatever. We call it here CMap. Okay, color map, and send this color map array to this color map. Then whenever there is a drawing, the MATLAB will use this color map, okay, to draw your image. Then here, you know, each color has its own mixture of RGB, red, blue, I'm sorry, red, green, and blue. Okay. And you know, white is just the three together, 1, 1, 1. Black, no light at all, no R, no G, no B. The red is only 1 here, 0, 0. So we only one red, one component, and so on, so forth. The gray is a midway of black and white, so it's a half, half, half. Okay. So again, don't worry about this. Okay, this is just for the visualization part. Okay. Now to draw this, we need is a map. So we're gonna create, and this map should have, each cell in the map should have a number that represent a color from these colors. So when we draw it, it will draw in that cell a certain color, plot a certain color. So for example, if we put 1 in the map that we're gonna create right now, in some cell, this cell will have a white color when it's drawn. If I put 2 there, then it will draw a black cell. If I put 3, 1, 2, 3, it will draw the cell as red, and so on and so forth. Okay. So I have here the input map, which is just zeros and one. 0 means the free cell, 1 means obstacle, and I will get its rows and columns using this very simple function called size. So size of an array or a matrix will give you a vector. This vector, the first element is the number of rows of this input map or array, and the second element is the number of columns that array. In that case, of course, it's 10 by 5, 10 rows, 5 columns. Then we're gonna create this map, the map that we're gonna draw and visualize. Again, this map has certain color for certain cell based on the function of the cell right now. So I will initialize it as zeros in the beginning, okay? Then I will mark all the free cells with white. What does that mean? It means that these cells, these white cells here in the map array or map matrix should have 1, okay? Remember that input map, the array that we originally created in here, has a different type of stuff. It has only zeros or 1, or true or false. For the obstacles, it has true. For the free cells, it has false or zeros. Okay. So to mark the free cells with 1, okay, I use this very pretty function from MATLAB. You can, you know, send a complete array to another array, okay? And what you are basically saying in here, let's explain with this example first, then go back to this one. What I am saying in here, for any value or element or entry in this matrix called input map, if it's true, assign in the map here, in this array, 2, the number 2. Okay, so what will gonna here? What will happen here is as follows. Input map has zeros and 1. Okay, when I have the delta tilde, I'm sorry, mark here, this will flip the true to false and the false to the true. So the free cells will be ones and the obstacles will be zero. And what I'm saying in here, for any element in that new array, which is a complement of our original array, put one if true, other than keep the value of the map. So this is basically will assign ones, okay, to any free cell in the new created array called map. And this will create, okay, or assign the number 2 for any cell which represent an obstacle. And why 2? Because 2 is the black. Again, map here is the colorful map. Input map is just the original map that we created with just true and false, zeros and ones. Okay, but with the colorful map, we need to assign color to each cell. So I assign 1 to the free cells, which is white. I assign black, which is 2, to the obstacles. Okay? Okay. I will also assign colors to the start and the goal node. We will assign green for the start node. And I will assign yellow for the goal node. Okay. So let's do it. For the start node, it's really convenient in MATLAB to work with the ID rather than the coordinates. If you remember in the slide that I just showed you 10 minutes ago, each cell in the array here can have an ID. So this, for example, this cell here has coordinates of 1 and 1, but have ID of 1. Okay, this has a coordinate of 2 and 1, but has an ID of 2. Okay, and how MATLAB computes the ID, this is the equation here that converts any column index and row index into a single ID. Our start node is at column 3 and row 7, and the row size is 10. So just to compute this, it will give you 27. Okay? Okay. So the ID of a start node can be computed by MATLAB using this function here. It's called subscript to index. Subscript to index will take a subscript, which is in this case the coordinates, the column, the row, and the column, and also the size of the map. And it will give you a single number, which is in this case 27. Okay? Then we will mark the start node with green, and the green is number 5 in here. 1, 2, 3, 4, 5. Okay? Good. Exactly the same thing for the goal node. First, compute the ID of the goal node using the size of the map, the row coordinate, column coordinate, map of goal node equal to 6, which is yellow. 1, 2, 3, 4, 5, 6. Okay? We need also a variable to track the distance of exploration starting from the start point or start node. Okay? So I create here a variable called distance from start, and I assign 0 because the distance from the start to start is just 0. And as you remember, our first frontier, if you remember this from my demonstration, is a starting node. We need also to track the expansion, okay? And for this, I have here a variable called the step. Since we didn't expand anything, the step is 0. Now I create the what will be equivalent to a FIFO, or first in, first out, which is a frontier distance step array. I call it in that way so that you can know just from the name what is the first column will do, what is the second column will do, what is the third column will do. So the first column contains the frontier's ID. The second column contains the distance from the start. The third column contains the number of exploration step of such a particular cell or frontier. Okay. I create this, I initialize it first with infinity, you know, because it's like a queue. In C++, for example, if you have a queue and if you create the queue, it will have no size, and you just push into it, so the size will increase by 1. But here we create it from the first place, so it should be filled with something. So just not to mix with our numbers that we're gonna put afterwards, so I just put infinite. So if you see an infinite entry in one of the cells in this, or entries in this array, means nothing was put in there, okay? So you will notice something in here. It has a number of rows multiplied by the number of columns, and it has 4 columns, not 3 columns. When I first start explaining to you breadth first search in this lecture, I create the array with 3 columns. So the 4th column is actually a column that you will do in your homework. You will use it to construct the shortest path. So I will do is use the exploration only until we reach the goal node. Then you will do the shortest path by yourself as an assignment or homework. Okay. Our first entry in that array should be the starting node. So frontier distance step of 1 and 1, start node ID. The second entry should be the distance from the start, which is 0 in that case. The third entry, the exploration step, which is 0 because we didn't explore anything. And the 4th entry in that row is just infinite. Okay, you will use that later. The frontier pointer, yes. Now we need a pointer to look for the frontier nodes, which I call frontier pointer. Guys, give me just 1 minute. I will go back to you. Just 1 minute and I will go back. There is Zoom in here. Sorry, guys. So let's go back to the lecture. Okay, so we need, as I said, a pointer for the frontiers. Okay, and now we are pointing to the first entry in the queue, which is the frontier pointer. So I put here 1. Okay, let's get started. So here is a while loop. This loop, it will continue forever until you find the goal. Okay. So this is a drawing, the drawing part that I told you, okay? In each step, you should be sure always that the start node and the goal node is 5 and 6, okay? Is green and yellow. This is just an extra step just to verify that you always keep the convention. Green for the start, yellow for the goal. And this is the actual drawing command or function for the MATLAB. If you want to draw, if this is true, okay, draw the image. Don't worry about the details in here. Just use it as it is, okay? We set this to true, so whenever we reach in that step, we will draw the map, okay? Now, Let's get our first frontier. Our first frontier is the frontier ID cell or node that is pointed to using the frontier pointer. Okay? And where are our frontiers? They all lie in this array in here. So I will take this array in here. And where is the IDs of the frontiers located? They are located in the first entry of each row. So the frontier of the pointer and the first entry. Okay. So far so good. So far so good. Now this is a basic step in which you should confirm that this is not a goal. If it's a goal, then you are done. So we must check that the frontier node that we just calculated using this command in here is actually, if it's a goal or not. If it's the goal, we just break the while loop. We are done. If it's not, we just continue and explore more nodes. So if frontier node ID equal to goal node, then, you know, break. If it doesn't, just continue. Okay. Sorry guys, I have to finish until this point. Okay. We're gonna start next time from this point in here. Start. Let's write it. Start from here. Okay. We'll start from here. We'll complete the algorithm. Then I will explain to you how to do the assignment or what I want in the assignment. Okay. And as I say, the assignment will be basically finding the shortest path. You can now, you know, as a part of your study, you can just explore my code, try to complete it yourself. Okay, because it's not complete. There are some steps that need to be completed, like this one, for example. And of course, if you can do the homework from now, that will be very nice. Okay. One last thing, just a reminder, please send me the waiver and the safety forms that I asked you yesterday. Okay. I believe everybody got this email from me to sign the waiver and the safety forms. And for next Monday lab, since you haven't received the kits yet, I'm really not sure what's gonna happen. Okay, if we could manage today or tomorrow the drive-through, and you know, I don't know. So I will send you an email regarding next Monday lab. Okay, but 90%. By next Monday, you will not have the kit yet. I believe you should receive it next week, but not Monday. And we have a difficulty with the guys living outside Bakersfield. So maybe these guys the kits will be mailed to them. I'm not sure at this moment. Okay, but this is a solution for it, a potential solution. So maybe next Monday, we're gonna just continue with the BFS. So it's just a lab, it's a coding, so it can be considered as a lab as well. Okay, but I will let you know by some announcement on Canvas. Okay, any questions, guys?
Professor, just to clarify, so there's no assignments due so far?
No assignments. It
Okay.
was, I supposed to have your first assignment today after finishing the code, but you see now that we didn't finish the code. So next Monday, if we're gonna continue with the BFS in the lab session, then definitely you will have an assignment. Okay.
Okay. Thank you.
Thank you very much. Any other questions? Okay. Yes.
You're gonna upload this video, correct?
Yes.
Okay, then just
This
making
is
sure.
by default. Don't worry. Okay. Any other
Professor,
question? Yes.
you don't expect us to finish this before next lecture, right? Or the BFS code that you're writing right now? This is just a walkthrough.
No. Just walk through it. If you can complete it by yourself, that would be great. Okay. If you couldn't, just hold on until next Monday with 90% to complete it with me. Okay, this should be part of the lecture. I'm just giving you my ideas how I implement this code, just to make it easier for you to implement the assignment, which is finding the shortest path.
Okay, thank you.
Okay. Any other questions?
Just I don't know if anybody asked already, but is there going to be like a syllabus for this class? Because I haven't seen it yet or received it yet.
So I'm very sorry for this. I'm really very busy, extremely busy. Okay, and they assigned me this course, in July, late of July, I think. So this is not my expertise. So I just started from scratch. So of course I made a lot of good material for you for this class. Okay, but I didn't. And I am moving from another state, so setting up my my life here, so it was very hard for me to finish everything.
Of course, right.
So the syllabus is in my mind. But I believe within 2 weeks it will be on Canvas.
Okay, great. And another thing is, well, I don't know, I'm probably one of the very few, if maybe the only person in here, but I have never used MATLAB yet. So I don't know if is that something we have to just download from online and you just.
I think there is MATLAB license with Bakersfield, so CUC Bakersfield. So just download it. I'm not aware of the instructions because I'm new like you, but not to MATLAB. So I have my license from my previous university, but I believe there is a license. I believe 100% there is a MATLAB license for you here. But how to download, how to install it, and such kind of stuff, I'm not sure about.
You could also use the virtual computer lab from
CHGB. Yes, that's another. Yes, that's right. That's right. You can use the virtual computer lab to, computer to.
What's it called? I've never done that before. Is it something new, right? Like something that came out for this semester?
Yeah, just type in a virtual computer lab CHGB, and then you can access pretty much everything. You just log in into your regular ID.
You log in with your student information.
Let me put a link in the chat.
Thanks, man. Appreciate that. All right. Sweet. Thanks, guys.
You can post on the forum on Canvas, for example, how to install MATLAB. Somebody will reply to you from the class here, okay?
Okay.
So I think it will be easy. I believe so.
Yeah, I hope so. I think so.
And MATLAB is the easiest language, programming language that you're gonna use. Although, of course, it's licensed. So, for example, there is no queues. If you wanna use queues, you have to have the license for it. So I couldn't use, for example, the FIFO queue here. So that's the basic problem with MATLAB. It's not a free programming language, like pretty much every other programming language.
Okay.
Okay, guys. Any other questions? Okay, have a very nice day. Okay. See you. Bye-bye.
Bye.
Just a quick comment.
Yes.
I just wanted to suggest, for future lectures or PowerPoints, could you possibly upload them in advance before we have the meeting?
You want me to upload the lectures before the meeting?
Yeah, just to follow along,
I understand. Okay, I understand. But these are basically the same slides from the last.
Yeah. I'm just saying, for future. Yeah.
Yeah. Okay.
All right. Thank you. Appreciate it.
Thank you. Bye-bye.